It's called the hydrologic soil groups. It's a measurement of water moving through different soils, primarily under saturated flow. And there are 4 of them. And luckily, good old soils people like myself, we turned around and kept it simple and called them A, B, C, D. So these are the 4 different hydrologic soil groups, and they're related back to infiltration. So one group infiltrates really fast, which is kind of cool. Others infiltrate really slow. Can we manage them all and improve them all? Absolutely. And those are some of the tools and materials that we're trying to come across and show you where we have. So let's go through these 4 hydrologic soil groups and talk about them. Hydrologic soil group A. These would be the soils that have large pores and transmit water quickly. So these soils then would have high infiltration. They would allow the water to go through very rapidly. If it has high infiltration, then it's going to have slow runoff. Generally speaking, these would be the soil types that develop from, say, coarse geology or coarse textured soils, i.e. the sandy soils, granitic rocks, a coarse sandstone, dune lands, those type of scenarios, particularly these really coarse sandstones and granites that we have around here. And this is an example of hydrologic soil group A. The same amount of water was all in these soils, air dried. And so if I look at A, it's pretty loose, pretty open. And this would be mainly from granitic materials. Even in San Luis Obispo, we have granite. And by the way, I think I heard the question earlier, granite is our base rock for the United States. That's our overall base rock for the whole Pacific continental, the continental plate that we have. So if I was able to take you to Grand Canyon, we're going to go down about 5,000 feet of sedimentary rocks, and then all of a sudden you go pop. And at the very bottom, you find the granitic rock, and that's our base rock all the way across continental United States. And that's why you see it pop up when erosion and volcanism and so forth and so on. So the hydrologic soil group A's. Good news, they infiltrate fast. Bad news, unstable. These guys can just move. All right? There's no cohesiveness to them, so they will move. So stabilizing them with some of the tools we're going to give you, vegetating these, and improving their structure by adding things like compost and roots. Really stabilize and strengthen these soils a lot. B's. B's, still pretty loose. These would be more of the medium textures, the loams, the sandy loams, some of the silt loams. So these have some clay in them, probably still dominated by a lot of sand. They'll have kind of the coarse to medium pores, and they do okay for transmitting. Trouble with B is, though, they have more silt in them. Consequently, when water moves through them and they're not held together or bound together, these soils will turn around and collapse on you. And the pores, which are medium-sized pores, will begin to seal up with the silt, and then you cannot infiltrate water very fast. And if I don't infiltrate water very fast, then they will tend to have higher runoff, which is what we do not want to have. You can hold these soils open, but they need lots of organic material. Compost, topsoil, duff, incorporate it back in. Right? So B soils should transmit rapidly, and under a natural state they're okay. But on a construction site, these soils will tend to have some difficulties. C. This one's starting to clump more. Still loose, but starting to clump more. You can see some of the clumps in here. These are more of the clay loams, sandy clay loams. These are the medium to fine textures. I can even have clays in here coming out of the granite, certain type of clays. It's called kaolinites. Hold together a little bit better, and they aren't as sticky and gooey as some of the others. This soil here also will hold on to a lot more nutrients and hold on to a lot more water. Consequently, for growing vegetation, these are really good. They are probably one of the more of the stable, and I'll get back to that in a moment, of the hydrologic soil groups. So guys, when you're out there in the field and you're looking at it, just call up Mother Nature and say, I want C, please. Okay? And we'll be in good shape. Or if you're doing borrow, ask for C, hydrologic soil groups. Obviously not real, but if you do have C, and this is the material you're working in, this is probably going to be the easiest of the hydrologic soil groups to work with. As long as I maintain them and keep the structure open, which is something we can change. We cannot change the textures of these soils. What you see is what you get. But we can change the structure, the pore size, the aggregate stability. And that's what we work with. Topsoil, duff, compost. C's, nice to work with, medium to fine, and we do okay. D's. D's, I kind of go, duh. Okay? These are the problem childs in one perspective. And that is, these are the shrink swell clays. They glue themselves together extremely tight. Commonly, serpentinitic rocks. That's serpentinitic, gooey gumbo clay, as sometimes it's called. If not maintained, these guys will swell up on you. They will just swell up and suck up a whole bunch of water. And then they become very heavy. They are slimy when wet. But they're extremely cohesive when dry, and you put structure together. So if I would take a smooth slope and just compact it to 90% or more, and it's made out of this high shrink swell plastic clay, it will sit there very nicely for you. But eventually it's going to suck up water, it's going to expand on itself, it's going to seal up underneath, and it's going to weigh a whole bunch. 3-to-1 slope, okay. 2-to-1 slope, not even too bad. 1.5, 1 to slope, this thing will just slump on you. It won't slide like the granitics. It won't slip like John was talking about on the granitics. This whole thing will just ooze itself down the hill in a slump. Sometimes even worse as a rotational slump as it moves on down. A question was asked, if I have D soil, let me add A soil to improve it and maybe make it something else. Got to remember in California, Mediterranean climate, most of our soils contain sands, contain clays, and we also contain other things like lime and gravel. So if I take gravel, sand, lime, I am making concrete. Do not try and add texture to texture. Mother Nature doesn't do that. If I have this and I want to make sure it doesn't run on me, or if I have this and I'm trying to make sure that it just doesn't swell up and not move anywhere, then we need to use what Mother Nature uses. And that's going to be something to keep the pores open, or in this case, glue the soil together. And that's going to be microorganisms, organic materials. Not the coarse stuff like bark chips. Those aren't going to work for you, okay? So it's going to be the composted. And Caltrans now has the specs for certified compost. There are quite a few places around. Just as easily, local topsoil, duff material. The specs are in the toolbox. Really nice. These are described in the toolbox. So, ladies and gentlemen, these are the 4 that you get. These are what we work with, and they're all part even of the construction general permit. And blending these things together, please don't mix them together if you don't have to. And the way to improve all of these, to keep this one glued together, this one to hold up. And my last question that I'm going to kind of pose, the sandy coarse, the silty loamy, the medium clays, and the high shrink swell clays, if I look at all of these, my goal would be to help you see, okay, which ones are going to create a problem, which is going to be the worst. And notice I say which ones are problems, and then I said which one is the worst. And as you look at all of these, I'm going to go, okay, A, it could be a problem, but it's solvable because it's easy to glue those large particles together and keep the pores open, good infiltration. D, you're going to go, okay, the high shrink swell, blah, blah. No, you can actually handle that with incorporating coarser compost, good roots, different types of roots, the fibrous through some of the tap roots, different types. You can hold D together. C is the natural, probably the best naturally overall that you've got. because it has medium pores, some coarse pores, some fine pores that the clay does, but it holds itself together and kind of maintains itself. The worst hydrologic soil group is B. The reason being is it has the silt. The silt is the non-cohesive medium particles that float in water and make this thing just act like soup.
Kind of bringing it all home a little bit. We're still talking about drainage and soil a little bit and water. And kind of the other thing that we wanted to talk about, we showed a lot of the seepage type erosion. You saw that seepage coming out of the cut slopes in the decomposed granites, right? The water flowed into the mountain, and then when they made the cut, the water came out of the top. Seepage type erosion. What kind of soil was that? What was the hydrologic soil group? A. Very good. Very susceptible for that to happen in A. Also, Buckhorn Mountain. Let me give you another example. Buckhorn Mountain, this batholith, it's so fractured, and there's water just going in and out of the mountain because it's so fractured. That's why you couldn't find one kind of spring or anything. So you have a mountain that water is coming out of this mountain, and you build a highway prism against that. And the highway prism is compacted to 95%. That water's coming out. Where's it going to go? Can you just picture it? The piezometric pressure, the pore pressure builds up, and it finds its way through the material. It will find its way through. So a couple of mechanisms are at work. Though there could be overland flow or subsurface flow coming down through the mountain. It hits the impermeable soil fill and it finds its way through. And then we come up with this poochy, sapping kind of erosion down here at the toe. Now when this soil gets saturated and leaves, it oversteepens this part, and then this head cut starts marching up. But the mechanism is not really erosion. I want to point that out. Or also, the water can come down this way and go all the way through. So when this is going to happen, you're in a hydrologic soil group A and B. Number one, your red flag should go up, and you're going to be building a big fill. And then they say, the project manager says, I want you to build it at 1.5 to 1, which you go, wait a minute, that's steeper than its angle of repose. What do I need to do? What do I need to do? You might need some toilet paper. Okay? Now, if I am the fill right here, my belly, my beer belly is the fill, and that pressure is, that pore pressure is going out, I need to resist that some way, right? So I better be thinking of a way to either relieve the water or resist the pressure. This is going to be key to your design. So if we just put an erosion control blanket down there and the water comes out, the erosion control blanket is just going to flap up and you're still going to lose your material, right? So maybe we need to start thinking about wrapping it. Maybe we need not so much as a Hillfiker wall or a geotech, or maybe a McAferry at the least, or maybe it could be just as simple as a coir netting wrapping it. So be thinking, those are the principles we want you to be thinking about.